All right. My timer has started running, so it's time for me to start talking, just to make sure I can fit everything in this 1 hour slot. So good morning, welcome. If you saw my previous talk, welcome back. I'm doing back-to-back talks. This one is in a bigger room. It's hopefully a more it's a more advanced topic for sure. The previous one was about API security. We saw some really crappy examples and how to fix it. Now we're going to talk about something completely else. We're still going to break stuff and fix stuff, but we're going to talk about front-end security now. If there is such a thing, we'll talk about that in a second, and specifically for OAuth. So what we're going to talk about here is basically OAuth, just a very quick recap so that everybody is on board without going into too much details here. But OAuth and OpenID Connect are kind of everywhere these days, a lot of systems using them. And I always use this triangle-based setup to explain the relationship. So OpenID Connect is about user authentication, right? It co-opts an OAuth flow under the hood, but in essence, the question with OpenID Connect that we're answering is authenticate the user for me. So we're offloading authentication, not doing it in-app, but we're offloading it to a third party, an identity provider. It will handle authentication and gives us information about who the user is, and that's OpenID Connect. OAuth solves a completely different problem. OAuth is not about user authentication. OAuth is about accessing resources. In terminology of the specs, it's going to be a resource server, but in most applications that we're dealing with today, it's going to be an API. So I choose to use APIs. It makes things a little bit easier to talk about instead of saying resource server 15,000 times throughout a talk. That question is OAuth. And OAuth, this single arrow is like 13 steps or something to complete in an actual OAuth flow because it can get pretty complicated with the back and forth and redirect and user authentication and so on. But in the end, what we get is an access token. And the access token allows the client, the applications on the left bottom corner, to access APIs. And that's also part of the OAuth ecosystem, the ability to access a resource server, an API with an access token, which can do its authorization logic, and so on and so on. On the right side, it's a triangle, so we need a third leg, and the right side is the API making authorization decisions. That involves the authorization server, either very explicitly with token introspection or implicitly with signature verification on a JSON web token and so on. And that is essentially the ecosystem for OAuth. All right? In OAuth, the original spec, if you really want to feel old, the original spec is 13 years old, 2012. And it had like a couple of flows to use in practice, like the authorization code flow, the implicit flow, a flow we shouldn't talk about because it's like super deprecated, and a client credentials flow. And these things have evolved over time because, as you can imagine, 13 years ago, there were no mobile apps. There were no, well, maybe something, but not as we know today. And there were no single-page applications with Angular and React and Vue running in the front end. All of that didn't exist. We had some web interactions, but they were somewhat limited, and the focus was heavily on back-end applications. All right? So as these things evolved, we added security features to the flows and so on, and we ended up with settling on a best practice for about 5 years now of using the authorization code flow for user-involved scenarios. So forget about all the other ones. If you have a user involved, it's going to be an authorization code flow. All right, and on this slide, I'm going to explain like the concept of an authorization code flow. I'm going to skip over a hefty amount of details by design, because otherwise I would have to keep you hostage till somewhere after lunch, which would probably not be appreciated by you, by the organizers, and by the police maybe. So let's talk about the essence here. So in the essence, the user is signaling through the application like, yeah, I would like to allow you to access an API on my behalf. That's the question that OAuth is trying to solve. Whatever that scenario is, we're going to leave that completely in the middle. So the front end, the client, front end here is the OAuth client. OAuth client is like, yeah, sure, let's start an OAuth flow with all the parameters in there, like response type and client ID and redirect URI and all of that stuff. And it basically takes the browser to the authorization server to ask for an access token, right? And the browser will follow that. That's a navigation. The browser will navigate there, and it will ask the authorization server to basically honor that request. Like, hey, this application should be able to act on my behalf. Can you make that happen, please? And so on and so on. And the authorization server will ask the user, like, who are you? Please authenticate. If there's, of course, if there's an active session where the user has authenticated before, this question will not be there. But the first time, the authorization server will be like, who are you? And I'm going to authenticate with my username, Philippe, and my password, FluffyDog17, exclamation mark. That's my default slide password, not my real password. It looks very secure, but it really isn't, so please do not try to hack my accounts with that password. Trust me, it's not real. All right, so when that happens, the authorization server is happy. It knows that I'm Philippe. It knows that the client is allowed to access something on my behalf. Everything checks out. So it will return an authorization code, a temporary artifact to send through the front channel. This is the front channel. Where's my highlighter here? Somewhere stuck on my screen. There we go. The highlighter here, this is a front channel, so this is kind of untrusted, so we use a temporary artifact, the authorization code, to handle that. The authorization code ends back up at the client, the front-end application, and the front end with this temporary artifact can't do much except one thing. It can go back to the authorization server and exchange that code for tokens. All right, the authorization code is exchanged for tokens, and it obtains an access token and maybe a refresh token and so on. And with that access token, it can now access the API. So we have accomplished our mission. In this conceptual view, we eliminated the 13 to 9 steps. In reality, there's going to be a lot more involved. You have to use something called Pixie and so on, so on. The flow is a lot more complicated. All right, but for our basic understanding of what we're going to talk about in this session, this is enough. All right. In this conceptualization, in this implementation pattern, a front-end has a couple of responsibilities, right? Our front-end client, our Angular app, or Vue app, or React app has to do a couple of things. First of all, it has to act as an OAuth client. So it runs the OAuth flows. It has typically a client library to run that for you. You don't have to implement the dirty details yourself. The library will handle them for you, and you are good to go. It receives tokens, so it's also responsible for token management, right? The front end is supposed to handle token management, keeping track of the access token, the refresh token, using the refresh token when necessary, and so on. And then, well, actually I have some items to highlight that. And then finally, we have the responsibility of calling the API. So whenever we make a request to the API, we include the access token, typically in the authorization header type bearer, and we send the token. And that's how the API can make authorization decisions. And this is how OAuth in front ends is very often implemented. All right. Now, what happens when things go wrong? That's a very important question. What happens when malicious JavaScript runs in your application? That's in the front-end world, malicious JavaScript is one of the biggest threats, right? How can that happen? Well, if you went to Scott's talk earlier, if some vendor gets compromised and their JavaScript file is modified and you pull it in, all of a sudden you're now running untrusted code that might control your application. It can do crypto stuff, or it can attack OAuth, which is also possible. A second way that this can happen is with cross-site scripting. Cross-site scripting is basically a vulnerability where data from the user ends up in the application and gets executed as code. It's a mistake, it's a coding mistake, but it basically allows an attacker to provide malicious data which will eventually execute in the victim's browser inside the application. The exact details are out of scope, not relevant, but what matters is that cross-site scripting results in malicious JavaScript running in the victim's browser within the application. All right? So what can that do? Steal tokens. Right? That's essentially the component token management gets attacked. The malicious code is like, oh, it's an OAuth app, awesome, there's some tokens there, yoink, it steals the tokens, it ships them off, and it basically attacks the application. Here's what an attack scenario would look like. The application is running Restograde, it's a restaurant review application, it's my go-to training app, because I like great restaurants and application security, so you can put them together in a restaurant review app. More importantly, everybody understands how it works, so I don't have to spend half an hour explaining the training application to dive into that. So this is pretty understandable. What happens here? Well, we have some storage areas, we have the application running, and all of a sudden we have malicious code. That's the red part. Red is always bad here. Malicious code running, and that malicious code can do whatever it wants. And of course, it's going to steal the information, right? We read the data from local storage, and we send a request to a server controlled by the attacker. Our server, my evil domain is maliciousfood.com, just to stay in the theme. So we send a request to maliciousfood.com, and it will include the data from local storage there, and the server now has the access token or the refresh token, and they can abuse that token by calling an API. Well, the access token, not the refresh token. They can use the refresh token to get a new access token, and then abuse the API. All right? That's essentially what the threat scenario is for OAuth and single-page applications. This is not good, but also not earth-shattering. This is not like new insights. This is pretty well known. This also means that there are some countermeasures for this. For example, one of the recommended best practices is to use short-lived access tokens. If your access tokens are only valid for 5 minutes, if somebody steals them, they can abuse them, sure, but at most for 5 minutes. So that might be a good solution. Keep them short-lived. Then you have the refresh token, which allows the attacker to get fresh access tokens. And the guidance there is like, yeah, you can use refresh token rotation. A refresh token rotation basically means, I'll explain it in a second, that a refresh token cannot be used by both the attacker and the application. You can only use it once, and if somebody uses it a second time, things will break. And that's what the recommendations would be in this particular scenario. This pattern is highly common, but it's absolutely horribly insecure. So I've wasted a lot of time talking about the stuff you're not supposed to do. If you're at this point, you're probably like experiencing some deja vu. If you've been here 3 years ago, I talked about the exact same issue back then. All right? This is not a glitch in the matrix. This is kind of by design. So what's going on here is this has been a problem for a long time. And what I discussed so far used to be the recommendations in the spec for OAuth for browser-based apps. Like there's a separate spec for this, and it used to say like, yeah, there's some risk of XSS, but you can use maybe this with short-lived tokens and refresh token rotation, and it's kind of make things better. And oh yeah, there's like this other pattern that you might want to use, but whatever. That's in a nutshell what the old version of the spec used to say. And as a security expert and working a lot with frontends, this always triggered me a bit. Like, this doesn't make sense. Like, you can evade these issues, right? You can evade things like refresh token rotation. And I wrote like a lengthy message on the mailing list, the OAuth mailing list, and people were like, yeah. And that was kind of it. So I was like, that's not very efficient. So I decided, like, you know what? Let's do a talk about that. Let's tell people that the advice in the spec is really bad and that this is probably better. And that's what I did here at NDC Security. And the feedback from that talk 2 years ago was like overwhelming. People were like, holy crap. I was going to say something else, but holy crap. That's like not good. And they saw the light and they were like, yeah, this was really insightful and this was really great. And yeah, we actually should think differently about security and frontends. And I did the same talk that year at the OAuth security workshop, and that's basically where the people writing the specs are all together in like a friendly environment, and I did the same demos in their face, like here's how you easily circumvent these things, and they're like, yeah, that's not good. Now we understand, like seeing something is apparently a lot different than writing it out in a mailing list, because people have to make the connection to actually see it being done instead of hearing someone like, yeah, I can circumvent that. And showing that was actually kind of very important. And what the result was from that is like, we talked a lot about security, and of course it's a OAuth security workshop, and some other things. And in talking with the main spec author, I was like, we probably need to rephrase the advice a bit and change this a bit. And this eventually resulted in me becoming a co-author of the spec. And becoming a co-author is coded language for rewriting the whole thing. That's eventually what happened. You'll find like a major diff somewhere in around number 15, I think. Rewriting the whole thing and expanding the spec a lot. It went from like vague discussions like, yeah, something like this, to like a very concrete document. And that's what I want to talk about here today. Some stuff will overlap with the thing I talked about 2 years ago, but I'm going to add a lot of new stuff of what's in the spec. And the main contribution here is basically a fully featured or fully detailed threat model. Like, what can the attacker do when they have cross-site scripting access to the application? All right? And then we talk about implementation patterns. And the old pattern that I talked about before, which is really crappy, is still in there. If it were me, I would have deleted it, but apparently you're not really supposed to do that. Be that strict in spec, so people might want to use it. So what we did is we added like a threat analysis to that pattern. Like, hey, you remember these threats we had here? Like, here's how this scores against all of these threats. Like, doesn't cover this, so this is a problem, yeah, basically doesn't do anything security-wise. That's basically the conclusion of that pattern. Now, of course, we have the other recommended patterns, like using a BFF, and it can cover a whole bunch of these threats. And that's what I'm going to talk about here in this session. All right? So, you saw my name on the spec. The P stands for Philippe, which is very confusing. Thank you, French people, for that. The name is a French spelling, by the way, which is not very international and whatever. So who am I? I'm a security expert. I did a PhD in web security. And since my PhD, which is like ages ago, I've been helping developers understand security. I do that through conference talks like this one, to trainings, conference workshops. I did one here on API security, but also through very specialized consulting, helping them understand OAuth, understand the trade-offs, understand what to do, how to do it, and so on and so on. So that's essentially how I spend my time. I also volunteer for SecOpDev, which is a non-profit organization which runs a yearly AppSec course in Belgium. So if you ever need a reason to visit Belgium for a whole week, and your employer pays for that, SecOpDev is the perfect opportunity. So that's how you sell it to you. Don't tell your manager that I said that. Of course, you have to package this a bit. But what we do there is we bring experts from around the world to Leuven, to Belgium, to teach about application security for a whole week. We sit together for a whole week. It's very immersive. It's a small group. It's a super fun experience, and it's very, very great to learn about application security. All right? Enough about me. Let's almost start talking about OAuth again. If you want to grab a copy of the slides, that saves you having to take pictures all the time, which you can do, of course. If you want me to pose for a picture, you can ask it as well. I'll do that. But if you want to grab a PDF copy, you can find it here. It's also on my website, on my socials. You can easily find that. If you get my name right, then I'm very easy to find. If you forgot how to write it, it might be a bit more challenging. But the OAuth spec would be a good starting point. Like you can go there, and then you can at least get half of my name right, and then take it from there. Good. Let's talk about JavaScript. Everyone's favorite topic. Let's talk about malicious JavaScript. That's what it's really about. It's malicious JavaScript running in the browser. That's the problem here, right? We have a browser-based application, HTML and JavaScript, and all of a sudden, through some mechanism, which we can leave out of scope here, the attacker succeeds in executing JavaScript. And one of the ways that can happen is cross-site scripting. Right? Cross-site scripting is a major vulnerability. Actually, I found some stats from HackerOne, a bug bounty platform, and XSS is like the big bright yellow chunk on top. 23% of their vulnerabilities are cross-site scripting. And if you search like a vulnerability database for XSS, the results just keep coming and coming and coming. It's everywhere. It's very hard to prevent cross-site scripting, and when it happens, the consequences are devastating. And it's been a problem for a long time. It's basically been a problem since, I think, the early 2000s when somebody first discovered this attack. And that's when things went down the shitter, basically, and cross-site scripting started popping up everywhere. You may be thinking like, but single-page applications didn't exist back then. So even then, when you're building like these old traditional web applications, some of you may recognize yourself in this image. My apologies for that. You can beat me up after the talk in the corridor, that's fine. No, we do not approve physical violence. Old web applications had the same problem, right? Building server-side web applications, Java server pages, PHP stuff, Perl application, whatever you're doing, they had the same problem. We had a backend, and we had a browser, and we had HTML, and requests and responses, and we used cookies back then, right? Session cookies, because why not? And cookies are cool. I like cookies. And in essence, we had cross-site scripting back then as well. And cross-site scripting back then resulted in an attack called session hijacking. Right? Malicious JavaScript executing, and what would it do? It would steal your cookie, ship it off to a server controlled by the attacker, and the attacker can now use that cookie to pretend to be you as a victim. Session hijacking. Sounds familiar? Token stealing, cookie stealing, same thing, different data. Auto power off. My television is going to switch off in 55 seconds, so we'll have to deal with that as we go along. That's a cue to the people in the back, by the way. What's the solution here? The solution back then was like, yeah, you know what? We can mark the cookie as HTTP only, because that prevents the cookie from being accessed from JavaScript. It allows the use of the cookie on the network, but you can't read it from JavaScript. And that's essentially the solution that was pitched back then, and people believed that this would solve their cross-site scripting problems. And it really doesn't. There was even a misbelief at that point. Look at me, not at him, look at me. There was a misbelief back then that HTTP only fixes cross-site scripting. You can find blog posts saying like HTTP only cookies are a great way to prevent cross-site scripting, which is like, what? No. It solves like one symptom of the attack, like one potential consequence, but the attacker is still running code in the front end. In your browser, the attacker can do anything that a legitimate application can do, and it can basically, for example, send requests to the backend. If you're building like a server-side banking app, what can it do? It can send a request like add a new transaction to the list. It can modify the DOM to hide the transaction in your list of monthly payments or weekly payments, and then when you pay it, of course, the transaction will be there, and the attacker will steal all your monies. Something like that. Has always been a problem. Thank you, by the way. Has always been a problem. And we only also never fixed the issue. So what does this mean? This means that we kind of underestimate, as a general note for the community, we tend to underestimate the real power of cross-site scripting. Because we focus on this one super obvious attack. It's like if you think about somebody burglarizing your house, you think about, they might steal my gold jewels, while the attacker is just there to drink your booze, for example. And for some people, the booze might be worth more than the gold jewels, but that's again a different story. But that's the real story here. Cross-site scripting is about a lot more than just stealing data. And that brings us back to our front-end story. And the front-end story here is that the attacker can do a lot more. So we had this scenario. This is what I call the 12-year-old script kiddie approach. Like my first XSS, and like, oh, I'm going to steal stuff and abuse stuff. But a real attacker, they will think what they're doing. They will probably not be a script kiddie, hopefully. Well, I'm not sure if that hopeful is correct, but they will think about ways to compromise the application without running into these things like refresh token rotation. So what is refresh token rotation all about? Let me tell you why it doesn't work. Refresh token rotation, the concept is that the refresh token changes every time you use it. And if you use an old one twice, everything blows up, so to speak. Everything will stop working. That's maybe a less dramatic way of saying things. So in a legitimate scenario, the front end or the client, you can use it for other clients, but you shouldn't, but the client basically has an access token and a refresh token, and when the access token is going to expire, we use the refresh token to get a new access token and a new refresh token. And then when the second access token expires, we get a new set of tokens, token set 3, and when 3 expires, we get token set 4, and this keeps going until the authorization service says like, yeah, no, this is no longer valid. It's enough. You have reached the absolute lifetime of this chain. Refresh token rotation. Pitched as a solution. Why? Because the idea is that the authorization server will detect reuse. So at some point, the attacker will steal refresh token 2. Remember script kiddie going in, yoink, and abuse that. And the attacker is like, ha, I can use a refresh token. I'm so cool. And we now have access token 3 and refresh token 3. And the attacker can use access token 3 to access the API on behalf of the user and cause mayhem. However, when the application is, of course, unaware that this happened, there's no XSS exfiltration monitor tool, it just doesn't know that this happened. So at some point, the application is going to be like, hey, I'm going to use refresh token 2. And the authorization service is like, no. Alarm bells go off like a security alert in the logs, and it basically detects the reuse. And it assumes that this must have been because of a theft of the refresh token. And it basically revokes existing tokens. Like, it doesn't give the application new tokens, it also revokes any descendant of refresh token 3, so 2. So refresh token 3, 4, 5, 6, whatever, are now revoked. And that is how refresh token rotation is supposed to protect you. And this pattern takes or fails to take into account that the attacker can maybe be a little bit smarter and yoink and abuse. For example, what if the attacker waits until the application goes offline before using the refresh token? In that case, this happens, the red part happens, but the blue part never happens, so the green part never happens. Oops. And that's one of the demos that I illustrated or used to illustrate that refresh token rotation is not a security measure. It's just annoying, in a nutshell. It seems secure if you take these very strict parameters, but in essence, it doesn't really add much. Sure, it makes it a little bit more complicated, and maybe some really simplistic scenarios no longer work, but in essence, a smart attacker can easily circumvent this. So what does the attacker do? They steal data. And they keep stealing data. They don't use it, they just extract data, on and on and on and on. And then they detect until the application goes offline, and then they abuse the refresh token. And the application will not use the latest refresh token, the attacker does, and they can keep that chain alive for as long as this works. All right? Other ways would be the attacker can steal the refresh token and then delete it from the client, if possible. And then the client can also not use it anymore. It will fail, like, oh, whoops, something failed. But the attacker can keep going with the latest refresh token. And you can think of 1,000 variations of this specific form of attack. So the focus on token exfiltration, as the original spec used to do, severely underrepresents the capabilities of malicious JavaScript. All right? So let's do a quick demo of sidestepping refresh token rotation so you get to experience the in-your-face of why this does not work very well. What I have here in the demo is we have a demo application. We have a simple application using OAuth and access tokens. It doesn't do much except for using OAuth, basically. We can search for things, like we can search for test, and search, and then it says like we found 0 results because it actually doesn't search. It just says like, yeah, I couldn't find something. Basically like children, like, have you searched? Yeah, I couldn't find it. And then you go look, it's like, it's right there. Oh yeah, look at that. So this is basically a child version of a web app. What does this mean? This means that if you search something, it ends up in the page. It also has a cross-site scripting problem, just a tiny one. We can search for example, test, image, source is none. Oh, this image doesn't exist. So what do we do if it doesn't exist? Well, alert 1. Would be a good idea, and we search for this, and boom. Now we have cross-site scripting. Of course, cross-site scripting on your machine doesn't get you paid as a bug bounty hunter. Everybody can do that. That's very easy. You can just type alert 1 in the DevTools, and oh, look at that. The trick is, if you want to get paid as a bug bounty hunter for XSS, is me doing something on my machine that will trigger XSS on your machine. But if you look closely, a search feature is like notoriously vulnerable for this. This search term is also in the URL, so you can link to this. And if you send it to your friends, they can also see the results. And if you would load this URL in the browser, let's actually do that. Let's hit enter here. If you hit enter here, you can see that the code also executes. If I send you this link and you open this in your browser, it will pop up the JavaScript alert. The alert is the proof of concept, right? If I can pop up an alert, I can do anything I want. Just takes a little bit more effort than typing alert 1. But a little bit more effort is going to pay off if I can execute that payload. So how do we attack this? Well, first let's log in. This is OAuth. This is the whole authorization code flow. It takes us to an authorization server where you have to log in with a username and a password. Very uninteresting. And now we're logged in as Philippe De Ryck, and we have an access token. And you'll see that I've configured the application with very aggressive refresh token rotation. So it should start rotating refresh tokens in a second. There we go. And it keeps doing that very often, so we see this in action. In reality, you would not do that every 10 seconds or something, but you kind of get the idea. All right. So how are we going to attack the application? Well, let's take a look here. I have prepared a payload. This is what we'll search for. We'll search for test. And then, let me make this a bit bigger. There we go. And then we include an SVG, and the SVG is hidden, of course, and then we have an onload, like, oh yeah, if you load this SVG image, which doesn't really do anything, but whatever, then we include a piece of code from maliciousfood.com/js/attack.js, and that's how an attacker will come after you. That's all they need to launch this. What does this attack.js do? It basically steals your session storage and ships it off to a server controlled by the attacker. It steals your tokens. That's it. That's all you need. You can even write this as a single line if you really want to. And we do it every X seconds, and then we detect later if the application goes offline, and we abuse that. So how do we do that? Well, we go here. I can now search for this link. And my server is on the left. And you can see that we have stolen the refresh token. All right? And on the right, we are refreshing our tokens, and on the left, we're stealing the refresh token. And everything still works, and you see the heartbeat, like client application is still alive. That's something that will eventually detect, like, it's not there anymore, and off we go. So that's essentially what's going on. We can have to be careful with the timing here, otherwise the demo breaks. So let's see the latest refresh. There's the latest refresh token, and then let's see when the server knows about it. So let's navigate away, kill the application. All right, the application is not there. And on the left, we will detect that the application is not there, getting ready to abuse tokens, and there we go. And we can keep the refresh token chain alive, and that's why refresh token rotation is not a security measure. It's mostly an annoyance. It's a false sense of security, but it doesn't really help you because an attacker that's at least as smart as I am can write an attack like this. It's super easy, super simple to get this done in practice. All right. I'm going to kill this before the Azure guys kick me off for abuse, and we should be good. All right, so that's one. And this is kind of obvious, and this still has the issue of people saying like, yeah, but what if we can fix the refresh token? Maybe we can hide it in a web worker, and then the refresh token isn't accessible, and you wouldn't be able to do this, and we solved security. And of course, if you think about this, the attacker can do anything they want, right? So what else can we attack here? Well, what if we attack the OAuth client? The front end is requesting or doing an OAuth flow with an authorization code and exchange that code for tokens. What if we do the same as the attacker? There's no limit on how many authorization code flows you can run, because the front end, typically modern front ends, the libraries that you use, run a flow like this when they bootstrap. They don't store stuff permanently, they just bootstrap, empty, run a silent flow, obtain tokens, and now they're authenticated. And that's exactly what we're going to do right here. In the second demo, we're going to run a new flow. We basically set up a handler to receive the authorization code. We're going to use a hidden iframe to run the flow. We extract the authorization code, and we basically exchange that. Well, we run a new flow. Where's the highlighter? Great. Where's my thingy? Yes, here. Where's the other screen? There at the bottom. All right. We basically run this code. This code will run a silent flow using the existing session of the user with the authorization server. It returns an authorization code. We extract that code and exchange that code for tokens. This set of tokens will be independent from the application. So the application is working and our code is working. 2 sets of tokens, no overlap, no refresh token reuse, and a massive, massive problem in practice. All right, let's see that one in action. Same application, same setup, except that we need a new malicious server. There we go. What has changed? Well, the attack code has changed. So this is my new malicious server. The attack code is now a bit more elaborate. There's two ways to execute this. You can basically steal it using web messaging, or you can steal it from the URL. Both work. Let's run the first one, because why not? And we basically wait 5 seconds to launch this attack. It will run a new flow in an iframe. You can see here we create an iframe. We navigate it to the URL to launch the silent flow, and we then handle the authorization code and send it off to our server. All right, let's take a look at our server here. That's running. That's good. We can go here to the app.restoration.com. That's good. Let's log out for good measure and log in again. Otherwise, it uses the old refresh token it still has lying around, and that one has been revoked, so it fails. Just so you know, I'm not cheating here. All right, so the app is running. We have our new tokens in a second. In the meantime, I'm going to copy, there we go. The payload is the same as before, except that we now have modified attack.js, copy, and let's paste this one in here. Boom. There we go. 5 seconds, and on the left you should see the authorization code coming in. There was the authorization code on the top line. We exchanged that code for tokens. I've screwed something up on the right because it doesn't work. So the nature of live demos. My apologies. All right, let's see if this one is better. Otherwise, I'm just going to abandon the demo, and you assume that it works. Yes, now it works. Something with the refresh token, not sure what. But in essence, we have refresh tokens in the client and refresh tokens on our attacker's side, and they both work independently as we go on. And this is basically a problem that we can't recover from. Because you can focus all you want on protecting your tokens in the application. I should kill this. Protect the tokens in your application. But this shows you that there's no point in doing so. Because even if you manage to fully hide the tokens in your application, the attacker can always get fresh ones. Even if you build like a fortress, like the super most securest application ever, where you can never exfiltrate any token, the attacker just runs an iframe, extracts the authorization code, and runs off. It doesn't give a crap about your application. It doesn't hinder the attacker in any way. And that is a very, very big problem. And you can try additional security measures like Depop and so on and so on. It's not going to work because the attacker can do all of the same things. And that's a very important thing to remember. Malicious JavaScript code can do anything that you as a front-end developer can do. If you're building a front-end and you're like, I can do this super smart thing, the attacker can do the same thing. All right? And the conclusion here is, and that's a conclusion that's very unpopular with front-end developers, is telling them that they can't secure this. Trust me, since I've become a co-author, there's a lot of emails coming in like, yeah, but you can solve it with this. It's like, no, because of this reason. And there's like this whole back and forth going on about why that magical solution is unfortunately not going to solve things. And that's a very, very unfortunate and inconvenient truth. Trust me, I've told a lot of developers, like, yeah, you can't do this. And the first reaction is like, yeah, but... And then it takes a lot of convincing to get to the point like, oh yeah, okay, maybe you can't. So what does this mean concretely? This means that there's a couple of threats to front-end OAuth clients, and that's new stuff from the spec. First threat is stealing tokens, right? Single execution token theft, that's the translated to the 12-year-old script kiddie, like going in, stealing tokens and moving out and doing something with those tokens. All right, it can happen with access tokens, can happen with refresh tokens, and you can limit the duration of the attack a bit, and so on and so on. That's a very simple threat scenario, but it used to be the main one in that spec. What else do you have? Continuous token theft or persistent token theft. Basically, the attacker stealing tokens and always stealing the latest version of the tokens, which is already a problem because even if the attacker wouldn't be able to obtain a refresh token, if they can always steal the latest version of your access token, you're still in trouble, right? Which basically means that the attacker, as long as you're aligned, can steal your latest access token and use that token. That's not good. Third attack vector, acquisition and extraction of new tokens. That's basically running the new flow and obtaining those tokens and using them, because that's basically circumvents a lot of the security measures that are in place or are recommended for front-end clients. And then the fourth one is a nasty one, proxying requests via the user's browser. This is basically client hijacking, right? The malicious code in the front end can send any request from within the user browser. It can call the API with an access token. It can do anything we want. And that one brings us back to the image with the dinosaur. Is the same one we had with our old server-side applications, right? We can hide the cookie. There it actually does work. But the attacker can still send requests that will use that same cookie to the backend and can do whatever they want. Client hijacking. To be honest, that's the baseline. We can never solve client hijacking. That's just the nature of cross-site scripting. That's the nature of the beast. Now, this slide here, if you go look at the spec, the pattern for doing OAuth directly in the front end has all of these listed as relevant threats. And what we've basically done here, very dramatic image, thank you ChatGPT. What we've basically done here is we've made the situation worse by using OAuth. That's not good, by the way. We had our front end, and if we would have used a session cookie with the API, things would have been okay-ish. Still a risk of cross-site scripting, but by adding OAuth into it, we made it worse. We turned an online attack into an offline attack with a lot more privileges, and that's not good. And that's really not good. And that's the last of the depressing stuff. Like, we've reached the bottom, rock bottom here. Rock bottom is this slide, hence the very dramatic, like, oh my God, why? That's rock bottom. So let's move out. I have 20 minutes, I think, to dig myself out of this hole. So let's do that. All right. Traditional web apps are more secure than OAuth and frontends. Okay. What about OAuth in backends, right? Remember that when I said that the original OAuth spec is doing or is heavily focused on OAuth in backend clients? Well, if we look at OAuth in backend clients, these risks are not there. Which is like, what? Well, single execution token theft or persistent token theft from the browser. I'm not talking about somebody compromising the backend and stealing your stuff there. That's out of scope. We're talking about front-end clients. From the browser, there's no way to access server-side stored data. You can't execute JavaScript in the browser and magically get access to an access token or a refresh token stored on the backend server. Well, if that's possible, you have other issues. You shouldn't be focused on this one, but focused on solving that issue, because that is a bit more important. But backend OAuth clients, they don't leak tokens to the insecure front channel to the browser. There's no way to do that. There's also no way to run a new flow and impersonate the backend client to obtain tokens, because in one of the steps, the backend client is a confidential client, has to authenticate. At some point, when the backend OAuth client goes back to the authorization server, like, hey, can you exchange this code for tokens? The authorization server is like, only if you authenticate, fellow. What's your client ID and client secret or key-based authentication? And only then will the code be exchanged. So the attacker can still steal the authorization code. An attacker would still be able to steal the authorization code, but they would not be able to exchange it for tokens because they can't authenticate as the backend client. All right. What about the last one? Well, we already know the answer to that one. That was the baseline. We can't fix that one, and we can't fix that one here. The attacker controlling pages in the browser can still send requests to the backend, can still make the backend do things in name of the browser. That's client hijacking, and we can't really solve that problem. All right, so based on this slide, we can conclude that OAuth and Frontends increases the attack surface. By moving OAuth into our single-page application, which seemed convenient, we have increased the attack surface. We have made the security significantly worse. That's how you sell what I'm going to talk about next to your boss, by the way. We made it worse by doing this. Well, the other guys made it worse by doing this. That's how you really sell this. Not me. No, the other guys made it worse by doing this. I told them not to, but nobody listens to me. Now you have some proof. Philippe said so. You can use that as an argument, by the way. I fully approve that. Philippe said so. That would be perfectly fine. Ideally, your boss says, like, yeah, let's bring him in and see if he really says that. And then we both win. So that would be good. So the question becomes, can we have the security of backend OAuth clients in our frontends? Yes, we can. That's the whole point of the talk and the spec. We can by building a backend-for-frontend. By extending our frontend with a backend, this is a message that goes really well with front-end developers. Like, you need a backend. No, we don't. Yes, you do. No, we don't. But yeah, you need a backend. So what's the previous scenario? It's the front-end talking directly to the authorization server. There's no client authentication here. I'm going to stop doing that. There's no client authentication here. That's the whole issue, because if the attacker steals an authorization code, they can abuse it. All right? What are we going to do? We're going to extend this pattern with a BFF. And a BFF is a super dumb backend component. You don't think about this as a backend. You just think about this as a module of the front end that happens to run on a backend. That would be a better way of looking at this. It's not an API. It's not a backend system. There's no logic in there except for some very generic things. And that BFF will run OAuth with the authorization server. That's what the BFF does. All right? It's a confidential client. Let's see if I can get my highlighter here. Yes, here. This is a confidential client using client authentication and so on to talk with the authorization server. Token management is now a backend responsibility. With the front end, we use cookies. Cookies have a very bad reputation, but in this case, cookies are the perfect way to keep track of state between the browser and the API. Works like a charm, designed to work with the web, and if you apply the right security properties, which I'll talk about in a minute, these are actually good. And what do we do when we call an API? Well, the front end doesn't call APIs anymore. The front end calls APIs on the BFF, like /BFF reviews. And the BFF is like, the reviews endpoint? Of course, yeah, I know about that. It's going to take your cookie, use your cookie to fetch your tokens, attach an access token to that request, and send it to the actual API handling reviews. And that's how BFF works. All of these building blocks of the BFF are super generic and super simple. All right? So what does that look like in the elaborate flow? Well, the flow still goes through the front end. The user wants to log in or do something, and the front end will basically tell the BFF. The front end no longer starts a flow, but the BFF does. So we have to tell the BFF there's a login endpoint. We tell the BFF, like, please start an OAuth flow, or OAuth plus OIDC, whatever. And the BFF is like, yeah, I can do that, and it's going to be a redirect. It's going to redirect the browser, like, yeah, I need you to go to the authorization server, please, and the browser will follow that. At that point, the front end is no longer in the loop, just the browser. And the user authenticates and all of that stuff. And in the end, we get an authorization code, which goes via the browser to the BFF. There's an endpoint on the BFF, redirect or callback or whatever. And that's the authorization code in step 7. And the BFF extracts the authorization code from the URL and will now exchange that code for tokens. And it will go to the authorization server with client authentication, be like, hey, I got this temporary value, the authorization code. What does it mean? And the authorization server is like, oh yeah, that's for Philippe. Here's an access token, a refresh token, and whatever you need. Maybe an identity token, whatever. The BFF can parse the identity token. There's no authentication because there's no user database. There's nothing there. It's just an empty shell. So what it typically does is it stores the tokens or associates the tokens with a session. And then it tells the front end, like, yeah, everything is good. And the front end, at that point, will bootstrap again. The front end will reload. The cookie is set. The front end calls the BFF, like, hey, do we have an active session? And the BFF is like, yes, we do, because of the cookie. And it looks up the user's info, and it returns the user info to the front end, allowing the front end to say, welcome, Philippe. Awesome. That's what the BFF does. When we call an API, the front end will call an endpoint on the BFF with the cookie. The BFF will use the cookie, look up like, oh yeah, this is for this user. We have an access token, take the access token, forward the call to the API in 14, and the API will process the request just like before, and a response goes back, and everybody's happy. That's what a BFF does. All right. If you look at our components, right? What has changed here? Well, for the front-end developer, actually, I had this conversation like a couple of weeks ago, and the front-end developer was like, yeah, we implemented a BFF. Man, my life got a lot easier, he said. Why? Because you can rip out OAuth from the front-end, like this OAuth library, take it, throw it away. No longer needed. Awesome. Next, token management. There's no tokens. The discussion, oh, where do we store the tokens? Do we use local storage or session storage or maybe a web worker? Go away, we don't care. Cookies, HTTP only, and so on and so on. Cookies, done. Calling APIs, well, that component is kind of replaced with calling the BFF, so you still call something. You don't have to add custom headers. The browser will add the cookie for you, but you still call, of course, API endpoints. On the BFF, OAuth has moved to the BFF, OAuth client. We also do token management on the BFF and session management, and then we proxy requests from the front end to the actual APIs. All of these building blocks from the BFF are core building blocks of the web. OAuth clients, there's like 15,001 libraries out there that handle that for you. Just use one of them, and they will handle the whole OAuth flow. Token management, the library typically handles it as well. Session management, you can find plenty of session management libraries, like setting a cookie and so on, perfectly available. And then proxying calls, there's middleware enough for all languages to implement some proxy type activity. Right? You have UARP in .NET, and you have proxy middleware in Node.js, and you have something in Java, and something in Python, and something God knows what for God knows language. But it's going to be there at some point. All right. Sounds great, right? For security perspective, it's like, yeah, BFFs. But does it require a lot of changes? No, actually it doesn't. So in practice, the API doesn't change. Why? Your API receives a call with an access token. Guess what? Your API receives a call with an access token. 0 changes to the API. Awesome. Authorization server, configuration change. Like you transform your client from a public client with no secret to a confidential client with a secret, and that's it. Standard functionality supported by any authorization server out there. The front end, rip out OAuth stuff, and you're good. Okay, no, you have to call one additional endpoint on Bootstrap, like check session. It's a simple API call with a response. You can deal with that in 10 minutes, all right? You can even ask ChatGPT to generate that code for you. It should probably do a good job. Always be careful, probably is the keyword here. And then the BFF, yes, the BFF is a new component. It's something you have to deploy and configure. However, if you want to use a BFF and you want to build your own, because good stuff is built in-house, that's a sarcastic comment, by the way. It can be, but it doesn't have to be. But if you want to build your own, you can build a BFF once, and everything else is configurable. You give it a client ID, a client secret, the issuer URI of your authorization server, and a mapping of endpoints here, API endpoints here, to APIs. That's all you need. Everything else is configurable. So once you build it, once you've put all building blocks together, glue them together, you can reuse that BFF across your entire organization for all your front ends. You can even have one BFF serving multiple front ends. Why not? You should be careful, because that's a discussion I've had as well, to understand that the BFF belongs to the front end. You cannot move the BFF towards the API by putting that in an API gateway, because that's going to create confusion. The BFF is not an API level component, it's a front-end level component, meaning that per front end you have a BFF. If you're building like a suite of applications, you have a calendar, and you have a notes app, and you have an email app, and you have a forum app, and so on. Each of these would have a different client ID on the authorization server, so each of these would have a BFF. Of course, you can configure one giant, if you have like the super BFF, you can configure it to support 4 different clients with 4 different configurations, sure. But that's how you keep that thing straight. It's not per API, it's per front end. Every front end that would have a client ID would have a BFF configured with those client ID and secret as well. All right? Good. The cookie is used to keep track of the user's tokens. Cookies have this really bad reputation, which used to be true for a long time ago, but today cookies are actually not that bad. And for all the people thinking like, yeah, man, I hate cookies, I'm using tokens, because yeah, that's what we do, we use tokens and an authorization header. Guess what the authorization server uses with the browser to keep track of who the user is, to do single sign-on? Cookies. So cookies are always there. It's the only thing that works really well on the web, by the way. In this case, we use a cookie to keep track of the user's session. That can be a client-side session or a server-side session. You can keep state on the server, like traditional Java sessions or PHP sessions, why not? Or you can choose to push all of the state to the client. You can put all of the token stuff in a cookie, preferably, wow, they're slacking off next door, like 10 minutes early, let's stop here. Or maybe they leave time for questions, which I don't do, but whatever. With me, you just get more of me, and we can talk later if you have questions. What we're talking about here is you can put all of the data in the cookie and ship it to the browser as like one big cookie. In that case, it's recommended to encrypt that cookie. It's not mandatory. It doesn't really improve the properties of the BFF. The BFF stays secure, but it prevents info-stealing malware from going through your hard disk and stealing cookies from the browser and shipping them off. That would stop some sort of attack there. That's what I wanted to say here. How do you configure that cookie? Well, you add a whole bunch of flags and attributes there. You add the secure flag, the HTTP-only flag, the same-side strict flag, and you add the host prefix as well. All right? I'm not going to talk about what this means. They're listed in the spec. If you want to read that, it's a good way to get you to the spec. Or you can follow one of my security workshops, and I'll talk about the meaning of these things as well. All right, so where do we get that BFF? Well, you can build one. It's a fun exercise until you get to the dirty details, and then it's like, why did we try to build this ourselves? You can also use vendor-supplied BFFs or proof of concepts. Here's a proof of concept in .NET using YARP. It's from Manfred Steyer, if you know him. He builds Angular stuff. This is a good starting point to get some ideas. I don't think it's production ready, but what the hell. You can also find some other implementation patterns like token handler. It's basically a BFF without the name BFF. Or you can talk to the guys outside in the Duende booth, because they actually have a full-featured BFF. They're one of the first to do this right, because I've been talking to Dominic quite a bit about this issue as well, and they've been doing this for a long time as well. A lot of their customers use BFFs. I'm not associated with them, so just go talk to them and see if you can use their BFF library for your applications as well. All right? You'll find BFFs out there. It's becoming a bit more popular. I think the spec has helped, the awareness has helped, so you'll no doubt see a lot more BFFs pop up in practice as well. All right? If you want to build your own, I strongly recommend to stroll through the videos of previous conferences, because there has been talks about how BFFs make things insecure as well, because if you do it wrong, there might be problems with BFF and open redirects and stuff like that, so you definitely want to look into those as well. Brings us back to the threats to frontends with the BFF, and this slide looks a lot better. What we have gained here is we have made our BFF is now a confidential backend OAuth client, meaning that the attacks go away. There's no token theft. The attacker cannot read a cookie with the tokens. The attacker cannot read tokens if they're stored on the server, and the attacker cannot abuse them in that way. That's good. We can also avoid the new flow stuff, as in the attacker can maybe steal an authorization code if they control the front end. That's still possible, but the attacker cannot exchange the authorization code for tokens without the client credentials of the BFF. If the attacker gets those, you're screwed. It's done. You messed up. That's basically the conclusion. All right? The bottom one, client hijacking, still there. We can't fix that. It's been there since 2003, if I'm not mistaken, when cross-site scripting was invented, and it's still there today, because there's simply nothing we can do to stop it except get rid of malicious JavaScript, which is the ultimate goal, of course, like get rid of malicious JavaScript, but it's going to be a very, very hard and long road. And I'm fairly confident that if we keep the same model of mixing HTML and JavaScript and data together, that we'll still have cross-site scripting in 10 years, even with all our best efforts. It's going to be a lot better, hopefully, but it's never going to go away. It's inherent to how we build web applications. All right. With that said, the BFF does make things better. Because before, the attacker had an access token. And they could use that access token on every API endpoint that would accept it. Now, the attacker can send requests through our BFF, and that means that we can kind of limit to what the attacker can reach. So even if this API has 17 endpoints that would accept the access token, but the front end only needs 7. That means we can hide 10 endpoints, make 10 endpoints unreachable. That means we can very specifically expose the endpoints that the front end needs and reduce the attack surface for the attacker. That's good. You don't have to do this as a BFF, but you can. It's a good practice. Additionally, also optional, but additionally, the BFF sees all of the traffic from front ends. The BFF could be a good place to implement things like rate limiting or anomaly detection. If a front end sends you like maybe 10 requests per minute to read documents, maybe you should block something like 1,000 requests per minute, like, yeah, maybe you're not a legitimate front end, like maybe you go away, and you block that, or you raise alerts, or so on and so on. Pressure. I'm almost done, so no worries. You're thinking like, oh no, the coffee line is going to be so long. My apologies for that. So the BFF puts itself in a position where you can actually implement additional security, but it's completely optional. In that case, your BFF becomes very front-end specific, very use case specific. A normal, regular BFF is as dumb as a bag of rocks, if you want to call it that. It's basically a very simple component without any logic. It just has the OAuth stuff, session management, and proxying. All right? BFFs significantly increase security. To be honest, it's the only valid option for anything security sensitive. I don't care if you think your code is object of cross-site scripting. It may be now, maybe you did a very good job, but it's not. History teaches us it's not going to stay that way. History shows us that at some point there's going to be a problem. A BFF eliminates a whole range of these issues. It gives you security. It makes things a lot better. And I strongly recommend or urge you to adopt the BFF pattern for your applications. I also invite you to read the spec. I spend a lot of effort on it. Not that that's a good reason, but sure. I think it's a really good document. Other people have acknowledged that as well, so it's not just my opinion. It's all hearsay, but still. But it gives you a clear overview of the threats. If you're not convinced, good for you. If you're like, yeah, dude, what the? No, come on. Pfft, whatever, I'm going to do OAuth in the front end. Be my guest. I don't recommend it, but who am I to prevent you from doing that? The spec gives you a clear overview of the risks in doing so. If you consider these risks to be acceptable, if you're like, whatever, then sure, why not? It's just that you can now make an informed decision instead of having to read through the lines or behind the lines and find the actual context. It's all in there. I strongly recommend you read it. It's almost finalized, by the way. This is like a draft from a couple of days ago to fix some minor issues. It's in like the final last call stages at the IETF. I have no idea what that means because it's my first time. So probably in 3 to 4 months or something, we will have an actual finalized RFC, which will be really cool to see as well. All right? Good. Key takeaways. Using OAuth directly in a browser increases the attack surface. You can find this inconvenient. You can try to argue that it's not that important, but it is the truth. So you have to accept it. If you want to accept it and consider this to be acceptable for your specific use case, then okay, good. But at least you know what it entails. You should use a BFF to simplify the front end and optimize its security. A BFF makes the front end actually easier to implement and maintain. No more OAuth client libraries, no more OAuth stuff to update, and so on and so on. It's actually a benefit to use a BFF, apart from the fact that you have to deploy the BFF, of course. And the third takeaway is you should heavily invest in secure coding techniques to avoid cross-site scripting. Because the last attack vector never goes away. Once cross-site scripting happens, yes, we have not made it worse than it was 15 years ago, but it's still as bad as it was 15 years ago as well. So don't mistake these things as solutions for cross-site scripting because it's very much a dangerous problem, and you should apply secure coding practices to your front ends as well. You should use defense in-depth tools like CSP, and you should use technologies like trusted types to avoid mistakes during development, and so on, and so on. That remains incredibly important. All right? Final shameless plug, I'm doing an OAuth, online OAuth course. If you really want to know a lot more about OAuth, that would be a very good place to do so. It's 2 days, it's 4 mornings, but it's a 2-day curriculum where we dive deep into all aspects of OAuth, including front-end security, BFFs, API security, and so on and so on. So if you're interested in that, take a look if you can join there. It runs in February somewhere. It's in my calendar. That's important, but I think it's 9 or 10, the 9th or the 10th that it starts, but I would have to check. All right? With that, I want to thank you for being here. I hope you enjoyed the rest of the conference. If you have any questions, we have exactly 10 seconds. No, you can talk to me afterwards. I'm going to be here in the morning as well. So just grab me and we'll talk. All right? Thank you very much and enjoy.